Hello guys, Digital Principal and Computer Organization. The subject code is CS3351. Unit 4 Processor. In my previous video, I will cover topics up to 3 units. So this is the 4th unit, Processor. What is meant by processor? Processor is nothing but the CPU of the computer. In the 4th unit, you are going to study about the what all the functions are occurred inside the processor. How the instructions will be executed with the help of the processor to get the output from to the user. How the instructions will be executed inside the processor. These are all the steps involved in executing the instruction. So there are 6 steps are used to execute the instruction in CPU, that is in processor. The first step is fetch instruction. For example, if the user is giving any message like hi, first of all it will fetch the instruction to the processor. So fetch the instruction to the processor. Afterwards, it will decode the information. So user given information is hi means it will be converted to the machine language. What is meant by machine language here? The machine language is zeros and one. Zeros and one. So the given instruction is fetch. First stage is fetch. Afterwards, it will decode. That means it will convert it into the machine language as zeros and one. The second stage in the instruction execution is decode the information. That is, it is going to convert into the machine language. Then it will perform the ALU operation. If the given instruction needs the ALU operation, that is arithmetic logical operation, means it will perform that operation. Afterwards, it will send to the memory. The processor data is sent to the memory, then update the register file. Afterwards, update the program counter. The program counter here is nothing but it is a kind of register. So first it will fetch the instruction to the processor. Afterwards, it will decode the instruction, then perform the ALU operation. So this is the instruction cycle or instruction execution in the processor. So it will be asked you in the 2 mark question in university exam. Fetch instruction. Afterwards, it will decode. The third is read address from the memory. Afterwards, execute the instruction to the. Finally, it will send to the user. After this step, it will send to the user. Next one is MIPS processor. This MIPS processor is one of the important question repeatedly asked you in the exam. So what is meant by MIPS? So this MIPS is nothing but million instruction per second. Million instruction per second. Per second. So this million instruction per second as processor has 5 stages. It is moreover similar to the instruction execution stage. First of all, it will instruction fetch stage. That is IF instruction fetch stage. So first, if you are sending the instruction means the first stage is it will fetch the instruction to the processor, to the program counter, that is in register. It is the program counter is a kind of register and store the instruction in the instruction register. The next stage in this MIPS processor is decode stage. Decode stage. After the fetching the instruction, it will send the instruction to the decode stage. So it will convert the instruction into machine language, that is 0 and 1. And the third stage is execution stage in the MIPS processor. In this execution stage, it will process the stages of a arithmetic and logic unit. Both it will perform the arithmetic operation as well as logical operation. And the fourth stage is memory access. So it will store the obtained data from the execution stage. And the fifth stage is write back stage. So it will write the result back to the register file, and noted that this include nearly all the instruction except no operation instruction. So this is the fifth stage of MIPS operation. So these are all the five stages of MIPS operation. So this is the one of the question asked you in the exam in part B as well as in part C. How the MIPS is implemented in the processor. So these are all the basic implementation of memory instruction per second. First one is the memory reference instruction, load data and store word. So first of all, it's going to fetch the data. Afterwards, they store the required data. Then it will do the arithmetic and logical operation of addition, subtraction and or not. The instruction branch equal and jump which we add, add loss. This subset does not include all the integer instruction. So these are all the basic subset of MIPS implementation, and this subset does not include the shift multiplied and division operation, or it also does not include the floating point instruction, that is it not accept the decimal point instruction. The overview of the MIPS implementation. The core MIPS instruction include the integer arithmetic logical instruction and the memory reference instruction and branch instruction. These are all the three instructions will be considered as the core instruction of MIPS. For every instruction, this first two steps will be similar for all the instruction. Okay, first it will send the program counter to the memory that contains the code and fetch the instruction from that memory. Afterwards, the second step is it will read one or two register using field of the instruction to select the register to read data. For load word, we need to read only one register, but most other instructions require reading two registers. Sometimes the instruction required only one register to read. Some for some of the instruction it will require two register to read the given instruction. These two steps will be similar to all the instruction. So this is the architecture of MIPS architecture. So it is constructed by using the program counter, instruction memory, register, ALU, and finally the data memory. All these are going to connect to give the final result of the instruction. In exam, you need to draw this diagram. From program counter, it is a kind of register. So the data will be sent to the address, and this address is sent to the register. In register, there will be a two or three registers are connected together. If it will do the addition operation, the addition operation data is sent back to the register. Afterwards, all the data is connected to the ALU, and finally it will send to the memory for storing purpose. So next topic is building a data path. How the data path is built inside the processor. So what are the way to build a data path in the processor? we will build a data path either in single cycle data path. Here we will each instruction execute a single cycle, and multi-cycle data path. Here the each instruction is segregated into a parts. Afterwards it will execute the instruction. So this is the difference between the single cycle data path and multi-cycle data path. In single cycle data path, it will be execute the instruction as it is given. But in multi-cycle data path, the given instruction is segregated into the smaller part. Then afterwards, it will broken execute the broken instruction. Then pipelined data path. Each instruction is broken into a series of steps, multiple instructions executed at once. In this my pipelined data path, the given instruction is first of all segregated into two or many. Afterwards, that broken instructions are executed at in a same time. So data path elements. What are the elements are used to build a data path? The three elements are required to build a data path. One is instruction memory and program counter. It is a kind of register. Afterwards, adder. So the instruction is sent to the instruction memory. Afterwards, the instruction memory send the data to the program counter. Then the program counter send the instruction to the adder for arithmetic logical unit operation. So this is the main element to build a data path. So the memory unit is used to store the data of instruction and supply the instruction to the address. Then program counter or instruction. The another name of the counter is instruction address register. It is a kind of address that hold the address of the current instruction. So the purpose of using the program counter is it will find out the address of the instruction of every instruction. Types of element in data path state element. The first one is memory element and arithmetic logical instruction, then collection of register. These are already considered to be the types of element. And the next topic is pipelining. This pipelining topic is one of the very important topic in this fourth unit. What is mean by pipelining? What is the need of using the pipelining in the processor? Pipelining concept is introduced because of, for example, if you are sending two or three instructions at a time, means instruction 1 will be instruction 1, instruction 2 and instruction 3. How will you send this instruction 3 instruction without a time delay? First of all, you are going to send the first instruction, right? You need to wait to send the instruction 2 up to you will get an output of the first instruction. To reduce this time, the pipelining concept is introduced. So this is the clock signal, right? So clock 1, 2, 3, 4, 5. I'm going to send the 3 instruction. First instruction is start from clock 1, 2. So there will be a pipelining. There will be a 4-stage pipelining and a 6-stage pipelining. In 4-stage pipelining, the clock pulse is start from clock 1 to clock 4. 1, 2, 3, 4. Okay. So first I will send the instruction 1 and the output will be received at the clock 4. Now I am going to send the second instruction, right? For that I need to wait for up to when the output of the first instruction will be executed. So I am going to send the second instruction. With the help of the pipelining, I will send the second instruction from clock 2 to clock 5. And the third instruction will be sent in from clock 3 to clock 6. Okay, see here the first instruction starts from clock 1 and second instruction starts from clock 2 and the third instruction will be start from third cycle, right? So in with the help of this pipelining, you can able to get the send the instruction three instruction with a minimal number of time. So here there will be a no overlap is executed. There will be a no collision is occurred with the help of the pipelining. How the pipelining is worked? The pipelining is segregated the given instruction into each segment. There will be two stages. One is 4 and 6 stage. In 4 stage pipelining, it will segregate the given instruction into the 4 stage. Afterwards, it will execute that instruction to get an output. So, the same principle apply to the pipelining. The principle applied to the MIPS instruction, that same principle is going to apply to the pipeline instruction execution. First one is it's going to segregate the instruction into 5 parts. The first stage is known as fetch instruction. Fetch instruction. So here it's going to fetch the instruction to the from the memory. Afterwards, it will read the register with decoding the instruction. Then third one is execute the operation or calculate the memory. Then access the operand in the data memory, and finally it will send the result to the register. Next topic is pipelining hazard. So what is mean by pipelining hazard? If the for example, you are going to send the 4 instruction or 5 instruction means instruction is executed with the help of the pipelining concept, there will be occurrence of some problem, right? That is called as hazard. For example, if you are going to send the 5 instruction means you can't with the collision problem, there will be a delay of fourth instruction. So that is called as pipeline hazard. How the hazards will be occurred? The pipeline hazards are usually classified into three hazards. One is structural hazard, data hazard, and control hazard. First one is structural hazard. What is meant by structural hazard? The problem is occurred because of the insufficient resources of the hardware. If the processor is facing some of the insufficient resources means that time the structural hazard will occur. And the data hazard. The data hazard is occurred because of the previous output. So instruction 3 is facing the issue means the instruction 2 output is not going to provide any result. So because of this the problem is occurred. So this problem is known as data hazard and control hazard. The control hazard is occurred because of overall problem of that particular instruction. So these are all the instructions of pipeline hazard of the these are all the three important hazards occurred in the pipeline. Okay guys, in my next video I will explain you how the hazards will be rectified and what are the steps involved in to recover from the problem that that are created in the pipeline. Thank you guys.